There are two problems that are associated with encoders. The first problem is, what if more than one out of the two power inputs are ones? What if more than one input are ones? The second problem is, what if no input is a 1? What do you think happens in this case? In the first case, there are more than one inputs which have ones. So assuming in this case here, for the 4 to 2 encoder, y1 is a 1 and y2 is a 1. What do you think happens in this case? Plug the values into this equation here and you get a equals to 1 and b equals to 1. Again, a equals to 1 and b equals to 1 is only true when y3 is asserted. But when y1 is 1 and y2 is 1, even then you're getting ab as 1, 1. And that is not the correct operation of an encoder. The second problem is, what if all the inputs are zeros? When all the inputs are zeros, your a will be a 0 and your b will be a 0. Just plug the values into these equations here. Again, a equals to 0 and b equals to 0 only when y0 is a 1 and y3, y2, y1 are zeros. So there is a conflicting nature here. So the solution is to use priority encoder. So if there are multiple asserted input values, then the input with the higher number takes precedence. I'm going to tell you what this means. So I'm going to explain it with a truth table to better understand this. 4 inputs, y3, y2, y1 and y0, and you have a and b. Okay, now let's take y0 is a 1, y1 is a 0, y2 is a 0 and y3 is a 0. Again, there's not a problem here because in this case AB will be 0, 0. Now when y1 is a 1 and y2 is a 0 and y3 is a 0, y0 can potentially take the values 0 or 1, right? Let's say it is don't care. Now since both the inputs can be 1 and 1, the input with a higher number takes precedence. Clearly, y1 is the higher number, therefore your output is going to be 0, 1. It doesn't really matter what y0 is, given that y1 is a 1. Similarly, when y3 is a 0 and y2 is a 1, it doesn't really matter what the values of y1 and y0 are. y2 has the higher number, so it's going to take precedence. So it's 1, 0. When y3 is a 1, it doesn't really matter what the values of y2, y1 and y0 are. y3 has the higher number, so it's going to take precedence and you get the output as 1, 1. So that solves the first problem, the condition where there are more number of inputs that are ones. Now what if no input is a 1? It's still not handling that, right? When no input is a 1, which means all inputs are 0, zeros, we add another output signal called the valid bit. When all the inputs are zeros, your valid bit is going to be a 0, and you really don't care what the values of A and B are. And if at least one of the inputs is a 1, then your valid bit is a 1. This is the functioning of a priority encoder. Priority encoder has several applications in microprocessors. Let's assume you have device A, device B, device C, and device D. All of them want to access a processor for resources. So microprocessor. Now we are going to connect them using a priority encoder. So we can use a 4 to 2 priority encoder to connect it to the microprocessor. Here, assume that A is a safety critical device, so it has the highest priority. So whenever A wants to communicate with the microprocessor, it is given the highest precedence, which means you don't really care what the other devices are doing. A is granted access to the microprocessor. B is given the next highest priority, C is given the next highest priority, and D gets the lowest priority. Right? So this is where a priority encoder is used. Whenever you have a situation where one device has it's much more critical to the system, then that has to get access to the microprocessor for resources, and a priority encoder will help us do that.